Hello everyone, this is Sam from HiPi. Today we're going to be looking at the k-nearest neighbours algorithm. The k-nearest neighbours algorithm is a supervised algorithm which will take in our data points and it'll also take in the classification of those data points, and then it'll build a model so that when we put a new data point in, it'll be able to classify what kind of category that data point is in based on its k-nearest neighbours. So you might be asking, what is k? K is just a number that we choose to tell the algorithm how many neighbours it has to look at before it categorises something. The benefits of having, well, we'll look at the benefits and negatives of different k's later on, but first let's look at actually how the algorithm works. We have here a load of pre-categorized data. We have red triangles and blue squares. We put in a new point, which is our green circle, and then if k equals 3, we look at the 3 nearest neighbours. We have 2 red triangles and 1 blue square. So here we would choose red triangles, so this green square would be a red triangle. If we extend this to k equals 5, we will see that we have 3 blue squares and 2 red triangles. I almost got my squares and my triangles mixed up there. So we would actually categorize this green kind of circle as a blue square. So we can see here that the categorization of certain points depends on what k is. So let's scroll down on the actual guide just to see what's actually happening here. We'll get to see this data later, so this is kind of a bit spoiling the end result. But when k equals 1, we see that there's a lot of kind of definition here in the kind of points where the data plays nice, where it's kind of nice and separated. But down here we have weird islands where the data just isn't being very helpful. Whereas when we go down to k equals 15, we have a lot less definition. We have a lot of a smoother line here, but we also have some points where intuition would tell us that the algorithm's gone wrong. So somewhere like here, the algorithm says it's green, but I would say it's red. Obviously, we have data points which are kind of like a little bit weird here and here, but these are just classed as anomalies. But in general, in the space, we're worried about sections like this section over here, where I would say is a red section, but that's open to interpretation, I guess. And you can disagree with me as well, that's fine as well. You might say that the algorithm's working fine. But essentially it's just a sliding scale. We can see weird things happen in different areas, and we just want to choose the right one for the job. And the way we do this is by the elbow method. I explain the elbow method in the k-means clustering video or guide, and we will see, well, we'll have a look at that later. But for now, let's get into the coding and how it works. So I'm going to drag this over here. Oh, that's not what we wanted to do. Let's actually drag that over there this time. And we're going to scroll to the top of this. So we're going to import the modules that we need. I'm going to copy and paste this. So numpy as np, pandas as pd, matplotlib.pyplot as plt, and then this new one, k-neighbourhoods classifier from sklearn.neighbours. We are then going to import our data, so read.csv, and the data is going to be called knn.csv. And we are going to be looking at the head and the tail of this, so head and tail, df.tail. And no attribute.readcsv yet, because that's a dot, not an underscore. And print is not defined. That's 2 good errors to start off our thing. And we can see that we have x data and y data for a 0 class, and x data and y data for 1 class. This is just the top and the bottom of the data frame, and this is sorted by class. So we can see here there's 2 classes, 0 and 1, and then just x data and y data for each one. So we're going to be working in a 2-dimensional space. Then we are going to be looking at a graph of what's going on here. So this is very simple because we have it in a pandas format already. So we're going to be doing a scatter of df of x data, and as our x values, y data is our y values, obviously, and we're going to set the color to be equal to df class. So the color will depend on the class. That gives us the actual plot, but we need to actually show it. Show, and we'll see we have 2 kind of clusters or very kind of distinct areas of our graph that we want to categorize. So how do we do this? First off, we're going to need to kind of clean our data a little bit. We need to, the actual algorithm will take in 2 different numpy arrays. One is the classes and one is the x data and y data of each point. So right now we have 2 columns, our x data and our y data, which isn't actually that helpful because that just gives us a list of x's and a list of y's, which is helpful in this situation, but what we want is a list of every single point, so an x value and a y value for each point. So pandas comes up with quite a nice way of doing this. If we do data df.drop class and axes equals 1, this will get rid of the class column from our data and store it into a new kind of thing called data. And then if we do dot as underscore matrix, and then this, we will then change this into a numpy array, which will have a list of points where the points are just the rows. So in this situation, we get rid of the classes and then we perform that method. So we will end up with just a list of points and each point will be the x value and the y value. So if that's not clear straight away, let's just look at the data. We will see that we have the first point is 27.1 and the second one is 28.3, and then we have the x data, it's 27 and 28.3 as expected. So everything's paired up quite nicely. And it's always good to look at your variables just to see what's going on under the hood. So then we're just going to say classes equals df and then class, which is just our classes. Then we're going to look at the actual the method that we're going to be using. knn equals k neighborhood classifier. We're going to set k equals 3. Sorry, k equals 5 for this example. We could do k equals 3, why not? And then we're just going to fit this. So we're going to do fit.fit, and then it takes in 2 arguments, the data and the actual classes. So here we will see nothing comes up because we're actually not looking at knn. I'm just going to say knn just for the sake of argument, and we can see the algorithm is automatic, and there's just a load of information here which if you look into and read about k nearest neighbours, you'll understand it better than I do. I just know how to apply it. And then what we can do here, which is going to be as far as we'll go for this kind of section, we are going to look at a list of points, and then we're going to predict those points. That's not how you spell points at all, that's a car crash. Equals, and then it's just a list of actual xy points. We have 0, 0, which we're going to look at. We're going to look at 40, 40. We're also going to look at 30, 30. So we have 0, 0, we'd expect it to be the 0 class. We have 40, 40, we'd expect it to be the 1 class. And we have 30, 30, which we're not really sure, and we're just looking at just for some fun. So then we're going to do print knn, oh my word, knn.predict, and then points. So points is just a list of points, and when we do shift enter we'll see 0, 1, 1, so we expected these 2 points, and then we actually found out that 30, 30 would end up in the in this group, the yellow group of points. So I would really heavily recommend looking at the guide for this one. We actually go out to look at how to code so that we actually get the area of what's going on here. So I'll just drag this over here again. We'll look at how to get something like this. I'm not going to sit here and explain it because it'll take a little bit long. But essentially it involves kind of plotting a load of different points. We create kind of like a 2D matrix of points, and then we predict every single one of them, and then we use some clever plotting to get that going. We can also look at how to change this into a for loop. So we look at different values of k, and then we have a mini project, and then just a mini project view here. We have some project training data, which we're just going to be extending into a 3D example. We're going to keep it abstract for this one. So we have 3D data, and then you can try plotting it using matplotlib. That's a little bit of a challenge in itself, but we have a load of test data here which I want you to just test and see which kind of category these test data fall into. So next time we'll be looking at another method. I hope you have fun with this one, it's quite interesting, and I'll see you in the next video.